Good day, grade 9 science students. Today we're going to learn about ions. I'm starting with a video here from YouTube, and this YouTuber is showing you how our body conducts electricity. Let's hear what he has to say.
Look at this. Your brain is connected to the rest of your body through a network of nerves. Your brain, as well as these nerves, are made up of billions of specialized cells known as neuron cells. These neuron cells make electricity through a process known as cellular respiration. When food you eat is combined with air you breathe, this creates a chemical reaction that produces energy. Some of this energy is electricity. When neuron cells are at rest, they are negatively charged, filled with potassium ions or charged potassium atoms. Sodium ions are kept on the outside of the cell's membrane. When a neuron receives an electrical impulse from another neuron, it releases its potassium ions and is quickly filled in with the sodium ions. These sodium ions steal electrons from the potassium ions and begin to pass their electrons onto other sodium atoms. Moving of electrons is known as electricity. This information is then passed on to another neuron cell through a gap known as a synapse. Chemicals are passed through this space and enter the head of the other neuron cell. This information is passed along thousands of neuron cells until the brain signal is received by the body part you want to move.
Okay, I know that was a lot of information to digest, and I don't expect you to understand a lot of it yet, but in order for us to understand it, even to begin to understand how I'm moving around and how I'm conducting electricity, I need to understand what ions are. And I'd have to know how atoms form ions, and that's what we're going to do today. And it's going to help us understand things like electricity flowing. Okay, so let's recall something. Each atom has one electron for each proton in its nucleus. This is known as neutral. When you have the same amount of protons and electrons, you are neutral. The number of protons tell you what element it is. Now remember, what is the element with 12 protons? Look at your periodic table, see if you can find out. If you're taking a moment, you should see that it's magnesium. Okay. So ions are charged atoms. When the number of protons is not equal to the number of electrons, the atom is now called an ion. Now, electrons can move because they're in the outermost shell. And an atom becomes an ion by either losing electrons or gaining electrons. So to become positive, electrons must be lost. Okay? Because if you start with the same amount of protons as electrons, if I lose electrons, now I have more protons. Okay? So therefore I become positive because protons are positive. To become negative, you have to gain more electrons. And that's what's happening. We become a certain type of ion if we are a positive ion. And I'm going to write it right in here right now. If you are a positive ion, you are a cation. If you're a negative ion, you're known as an ion as an anion. Okay? So an anion is a negative ion. A positive ion is a cation. And an easy way to remember this is that cats are a positive thing in your life. They make you live longer, believe it or not, because you have a pet. And anions are negative. Okay, let's look at our periodic table again. Here's some important things that you need to know. You should already have your groups labeled. They should have names. You should know that these are the alkali metals, alkaline earth metals, but this is 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A, and you know that each one of these groups actually tells you how many valence electrons you have. So if you're in group 4A, that means you have 4 valence electrons. And valence electrons are electrons in the outermost shell. You can also look at the period number, and that tells you how many shells will be around your Bohr-Rutherford if you're going to draw it. This is 1, this is 2, this is 3, 4. So if you're potassium, for example, if you're in period 4, that means you would have 4 circles around it if you're going to draw a Bohr-Rutherford. To understand what an ion is, if you're going to form a cation or an anion, we actually have to draw a Bohr-Rutherford and then draw, and then go from there. Okay, so if we look at beryllium, for example, we know it's in group 2. That means it should have 2 valence electrons. So if I had to really draw the Lewis dot diagram, it should look like this because it has 2 shells, but in the outermost shell it should have 2 valence electrons because it's in group 2. Okay, So let's take a look at this. Let's draw the Bohr-Rutherford for this though as well. It's got two numbers. It's got a 9 and it's got a 4. So that means it's got 4 protons, 5 neutrons. I have to subtract for the neutrons, and I have 4 electrons. So this is my first shell. This is my second shell. Here we go. Bam. Oops, sorry for that. I'll clean that up. That's what it looks like right there. So we have our Lewis dot, which is the outermost shell, and we have our Bohr-Rutherford, which is to the right. Now we look at this compound, we have to ask ourselves a question. And the question we're always going to ask, is it stable or neutral at this point? And if we look at this compound here is actually neutral. And how do you know it's neutral? We know it's neutral because it's got the same amount of positive and negative charge. And you should remember, we have 4 positives and we have 4 negatives. So therefore, it's neutral. Now, stable means full shell. You want to have a full shell to be stable. And if we look at this, we can see that it is not stable because it doesn't have a full shell. Remember, the shell holds 8? Well, it can't hold 8, or it's not holding 8, it's only holding 2 right now. So what's going to happen when it becomes stable? Well, the answer is it's going to want to get a full shell. And the way that we get a full shell is we either gain electrons or we lose electrons. In this case, we are going to try and I can either add 6 electrons to make it 8, or what I could do is just simply remove these 2 electrons, this one and this one. And then this whole shell is gone, and we would see we have a complete shell underneath. Okay, so if we remove 2 electrons, we'd have a complete shell. Now, we would no longer be neutral at this point. We would now be stable. Oops, sorry about that. We would now be stable. Okay? Now we would have a full shell. How many electrons do we have now? We now have 2 electrons. So question, if you've got 4 positives and you've got 2 negatives, what's your charge? Well, the 2 electrons cancel out with 2 protons. You now have 2 protons left. This has a positive 2 charge at this point. And the way that chemists would show this is they put a square bracket around this, and they'd say, you have a 2 positive charge. Bonus marks if you can tell me, is this a cation or an anion? It is a cation. And you will find that anybody in group 2 has 2 valence electrons, anybody in this group, and they will always form a 2 positive cation. So we're going to summarize this and say if you have less than 4 valence electrons, so this is group 4, this is 4 valence electrons, you will form a charge, okay? Have a positive charge, you will form a cation. We're going to learn that if you have more than 4, you will form what we call a negative ion, and I'll show you that right now. It's going to have a negative charge. Okay, here I've picked to draw the Bohr-Rutherford for nitrogen. But I know that it already should have 5 valence electrons because it's in group 5A or group 15, but that really means 5 valence electrons, and it should have 2 shells. I've quickly found out how many protons, electrons, and neutrons it has. So it's got 7 and 7. Okay, we know it's got 2 shells, so the first shell holds 2, and then the next shell holds 8, but I'm only going to place 5 because I have to place 7. So I got 2 in my first shell, so that means 5. So I half fill my 5 that I'm placing, and then I pair. It doesn't matter which one I pair. So again, this is great because we know it's in group 5, and you can clearly see when I draw the Lewis dot diagram that it's got 5. Now the question for you is this neutral or stable? At this point, it is not stable because it doesn't have a full shell. So we can say that it is not going to be stable. It is indeed going to be neutral because it's got the same number of positives and negatives. It's got 7 positives and 7 negatives, and so therefore it is neutral at this point, but it is not stable. Well, how's it going to become stable? The answer is that it's either going to lose or gain electrons. You can't lose protons and neutrons because they're in the middle. Now I could lose these 5, or I could gain 3. What's easier, losing 5 or gaining 3? You want to go with the lower amount either way, so we're going to gain 3 because that's easier. So we're going to put 1 electron right here. We're going to put 1 electron right here, 1 electron right here. We are now not neutral anymore because we now have just added, what did we just add? We added 3 electrons to become stable. Now, what's my electron count now? It is 10 negative. All right, so if you have 7 positives and you have 10 negatives, what's your charge? Well, the answer is going to be 3 because the 7 positives cancel out with 7 of the negatives. You're left over with just 3 negatives and you have a 3 negative charge. This is also going to be an anion because it's a negative ion that is stable. It is now an ion because it has a different amount of protons than electrons, and it turns out that everybody in group 5 forms a through negative charge because they all have 5 valence electrons. They will always gain 3 to get to 8. And that's the end of the video.